Hey everyone, Mr. Skelton here, back at it here with lesson 2 from unit 5, and today we're really going to break ground on really what this whole unit is about, which is similarity. And today we're going to start talking about similarity and really what that is and how it's different from what we just got done doing, which is congruency, right? We just got done doing all these proofs about how two triangles are congruent. And now we're going to show how two polygons or two figures are similar. And you're going to notice some similarities, pardon the pun, between them. So let's just jump right into it here. So you can see the learning targets there at the top, and you can read those here. I'll give you a second to read those. And let's just jump right into the vocabulary, okay? Two polygons are similar. This is the symbol. Kind of looks like a little wavy line here. You'll notice it down on some of these problems, like this example. That means similarity. That means figure A, B, C, D is similar to E, F, G, H. That's what similarity shows. That's what it looks like in terms of a symbol. Here's what similarity, if two figures are similar, here's the two criteria that the two figures must have in order for you to say that they're similar. Number one, all corresponding angles are congruent. Okay? I could spell congruent. All corresponding angles are congruent. What does that look like? Let me just give you a quick example here. If this was 50 and this was 60, and this is a bigger triangle, and this is 50 and this is 60. Sorry, my phone's going off there. So 50 and 60 make 110. So that would have to be 70 to make 180. And now, if you look at these two triangles, again, we're doing similarity. Similarity is different from congruency. These are obviously not congruent because this one's way bigger. But one of the criteria is that all corresponding angles have to be congruent. Corresponding, it means same location. Bottom left-hand corner is 50, bottom left-hand corner is 50. Bottom right-hand corner is 60, bottom right-hand corner is 60. Upper is 70, upper is 70. Okay, so that's what that means for number one. Number two, all corresponding sides are proportional. Now you just learned what a proportion was, right? Equal fractions, or equal ratios is what we say. Okay, so let me give you an example of that on this same picture. That's 2 inches, that's 4 inches, that's 3 inches, that's 6 inches, that's 10 inches, that's 20 inches. Okay? So take a look. All corresponding sides, key word here is corresponding. So what corresponds with the left side on the bigger one? The left side over here. So you'd write 2 over 4. 2 over 4. What corresponds with this bottom 3 on the bigger one? 6. Okay? And then what corresponds with the right-hand side over here, so 10 over 20. Now if you look at all of those, it says all corresponding sides are proportional. A proportion is equal fractions. Well, if you reduce all of these, what do you notice? You get 1/2 equals 1/2, which equals 1/2. That's what we want. That's what it means for all sides to be proportional. Okay? Now, some of you may be asking, well, Mr. Skelton, what if you went large over small, large over small, large over small, and just had these all flipped around? You would be fine. You would be okay with that. I would be okay with that. And sometimes in the directions, it'll tell you go from small to big or big to small. You just have to pay attention. But if it doesn't, you could have easily written 4 over 2, 6 over 3, and 20 over 10. And you would have had 2 over 1, 2 over 1, 2 over 1, you would still be good, okay? Now it says, notice what's the difference between polygon congruence and polygon similarity. Congruence is all parts equal or congruent. Obviously with similarity, the angles are congruent, which is the same thing here, but the sides are proportional. So the difference here is all parts are congruent. This is where the sides are proportional, which we just talked about, okay? Let's keep moving on here. A similarity statement is very, very similar to a congruency statement, a statement of two polygons that are similar. In other words, they have to meet these two criteria, okay? This is really the meat and potatoes of everything right here for similarity. That's what you got to know, okay? And so it says this is very much like a congruent statement. The big difference, obviously, is being that they're not equal to each other is the symbol, okay? Make sure that we're using this symbol in between and not using this. That means congruency, okay? The similarity ratio. We actually already, in the example that I kind of showed you, we already did a similarity ratio. It's a ratio of the sides, okay? And basically, it's what the sides all reduce down to. So I already did it right here. If I were to tell you that these two figures were similar, which is that's what it would look like, and I asked you what the similarity ratio is of this example, you would say 1/2, okay? So in that example, 1/2 or 2/1, depending on how you do it, would be the similarity ratio, okay? It's the ratio of the sides. So that's the gist of the lesson. Now let's apply some of this knowledge, and I kind of went through an example, and let's apply it down here on some other examples, okay? So this first one, example 1, says fill in the missing angles and sides. And you can look at these two diagrams, two figures, these two polygons, and you can rotate and flip and turn, or also notice sometimes what they give you, right? And so we know that they're similar based on this symbol. Similarity also means that the angles are congruent. So when it says angle E, yes, you can take this picture or this diagram and flip it and manipulate it to turn it just right, or you can just look at where is E. E is here, here's A, so I know it's angle A, okay? If I look at angle H, here's angle H, it's the last letter there, so the last letter there would be angle D. Let's take a look at our sides. Side AB is going to match up with BC. Again, AB matches up with BC. If AB over BC, so then you'd go EF over what? So AB over CD equals EF over GH. Okay. DC, so DC over HG would equal to something over EH. Well, here's E, here's H, so where's E and H on this one? A and D. Okay. If angle C is 127 degrees, what other angle is 127 degrees? Well, look over here. Here's angle C. What's going to match up with angle C on this one? Angle G. Okay. Sorry, my G kind of looks like a 6. That's a terrible looking G. Okay. Now, it says, are the polygons similar? And then it says yes or no. Now this is for example 2 down here. Let's take a look at this one. This one's kind of confusing and can throw some students off here. First of all, identify the shape. What shape do you have? A lot of students are going to say squares, but I know it's not squares based on 18 and 15 and 25 and 30. So these are obviously rectangles. And what a lot of students will do, it says if they are similar, write the similarity statement and similarity ratio of the first to the second. So they're telling you what order to put it in, first to second. Let's take a look here. Now, what do we know about remember, there's 2 criteria. So I'm going to write down the criteria again. Congruent angles. Do these 2 rectangles have congruent angles? Should take you 3 seconds to look at. They're all 90, so check. Good. Second criteria, are the sides proportional? Now, a lot of students are going to go, right side is 15, this one is 30, bottom is 18, bottom is 25, and they're going to do that wrong. Remember, you're trying to match things up. These are rectangles, so you want to match the long side of this rectangle with the long side of this rectangle. So, and it says from first to second, here's your first figure to second. So I'm going to go 18 and 30. 18 is the long side, 30 is the long side, so 18 over 30, and that has to equal the short side 15 with the short side 25. Now, you need to look at this, and you always need to reduce your fractions. So you can either take your calculator. I'll show you a little trick if you can see my calculator here. There's a fraction button on your scientific calculators, which is right here. So you can type in 18 fraction button, which is this one right here, and then type in 30 and hit equals, and it leaves your answer in fraction form. That's how you can reduce fractions, or you should be able to do this on your own. So you get 3/5 here. and then you can go 15, fraction button 25, and you get 3/5 there. So in terms of our two criteria, they check off, okay? So this one says similarity statement. We would say, and we can name this, you know, however we want. We just have to make sure we go in the right order. And so if these long sides match up, I'm going to go JMLK, JMLK. If I go JMLK, I got to go, and I'm going to kind of rotate this one this way. So it's going to be QPON. QPON. Similarity ratio we just found to be 3/5. So 3/5. Yes. Okay. Let's flip it over on the back. So a good problem here. Oh, let me get in the picture here. Use the diagram below to answer the questions. Okay. And so let's take a look at what we have. Looks like we have some trapezoids here. There's some given information down at the bottom. Two pieces of given information. Important. Parallel lines. Uh-oh. What do we know about parallel lines? What should you be thinking right now? You should be thinking AIA or CA or SSI. Don't know why I'm talking like this. All right. So QM is parallel to AK, and SV is parallel to PC. Okay. The two polygons are similar. Oh my goodness, that is big time information. They're already telling you, they are telling you that they're similar. So those two criteria that we've been going through, the two criteria again, just for your sake, write them out. Hit pause, write them out. Angles congruent, actually corresponding angles congruent, and corresponding sides have to be proportional. Those are the two criteria. They're already telling us that. Write a similarity statement. Okay, you can. I'm just naming these. You can name them. Just start at one letter and go in any order. I'll start at M. Okay, M-A-K-Q. M-A-K-Q is similar. Now I'm going to rotate this back up, and now notice 71 is here and 71 is here, so think about how you'd have to rotate this one to match up with that one there. So you're going to kind of turn it all the way around. So if I turn it around and I went M-A-K-Q and I turn it, I'd have to go P-S-V-C. Okay, and that may be tough to see right away, but you should be in good shape. Okay, now using what you know already about parallel lines, this angle here and this angle here are same side interiors, right? You kind of have this action going on right here. Here's 71, here's that. That's same side interior, right? So that's got to be 180 minus the 71, and that's got to be 109, right? That's got to be 109 there, okay? Now, again, if you take P, okay, and rotate P over, if you take this figure right here, I know my hand's in the way, but you rotate it, what matches up with this 118, right? You have 71 here. These are parallel, so that's got to be what? 109 here, because these two are same side interiors, 71 and 109. Those are same side interiors. 118, if you minus 180 from 118, that gives you 62 in that corner, because 118 and 62 are same side interiors, right? Okay, so what's going to be, what will be in this upper corner here? This should be 118, and then down here A should be 62. So I know when you look down it says to answer all of these, but I kind of just look at the diagram first and say, okay, what can I figure out, and then go from there. These are all same side interiors. If you notice, all of these equal 180 on these same side interiors. So now you're just filling stuff in. Angle Q, well, I already know what angle Q is. It's right there. Get it in the picture. That's going to be 109, M, 118, angle A, 62, angle S, 62, angle C, 109. Okay? Number 3 says, what is the similarity ratio of the first figure to the second? All right. Well, again, envision this being turned. So I guess my question to you would be, what matches up with this 8? What matches up with this 8 on this diagram over here? Okay. KA is 8. KA matches up with VS, so 8 and 6. So 8 over 6. Now, all I need is 1 because they already told me that the polygons are similar. So it doesn't say, well, it does say first figure to the second, so this is the first figure. Sorry. This is the first figure, this is the second figure in order. So back down here, and it says what is a similar ratio of first figure to the second. So reduce this fraction, right? Divide by 2, that'd be 4/3. So 4/3 would be our similarity ratio. Okay. Now, find the value of the variables. I'm going to kind of zoom out here because it's kind of important you see, hopefully see all of this, and I can keep it in the picture. Ooh. Okay. And the sun's coming through the window too, which doesn't make it easy. So you have to find y, which is right here, and you have to find x, which is right here. So what you're going to do is set up proportions to find these variables. Okay. Now I'm going to use this 8 over 6. I know that 8 and 6 match up with each other. So that's where I say I should see proportions. 8 over 6 equals. Now if I go this figure, first figure over second figure, I need to go y over something. Now, what does y match up with? Okay, 8 matched up with the 6. What does y match up with? Well, if you have a hard time again seeing it, MA matches up with PS, which is 12. So there's how we find y. Now cross multiply, right? 6 times y is 6y. 8 times 12 should give you 96. And you divide 96 by 6, and you should get 16. Okay? So y would equal 16. Now the other letter we have to find is x. Again, I'll do it in red pen, but I can still use my 8 over 6. I know 8 over 6 is 8 over 6 equals x is going to be the second figure. So what matches up with x, or PC? Well, here's PC. That means MQ. MQ is 6. So I'm going to have 8 times x, and 6 times 6, and 36 divided by 8 is going to give me 4.5. Okay? And again, that should all work out for you. Now it says, what is the perimeter of each figure? I'm going to zoom back in here, knowing that you can look at your, let's leave it like this, knowing that you can look at your picture. So I have 4.5 up here. I have, my y was 16. Now I didn't have you find K, excuse me, sorry. I didn't have you find QK. Let's find that, because it does say to find the perimeter of each figure. So I'm actually just going to call this Z. I need to find Z. So I'm going to use my black pen. I'm still going to use my 8 over 6 that I've been using. KQ is Z, so Z goes on top, right? Because I go first figure over second figure, first figure over second figure. What matches up with Z? What matches up with QK? Go back here. QK matches up with CV. CV is 9. So if I cross multiply here, I get 6Z equals 72. And 72 divided by 6 should give you 12. So that should give us 12 for our Z. Now, find the perimeter of each figure. Well, let's look at figure 1. I'm going to go 6 plus 16 plus 8 plus 12. So 6 plus 16 plus 8 plus 12, and that should give me 42. And my second figure should be 6 plus 9 plus 4.5 plus 12, so 6 plus 9 plus 4.5 plus 12 should give me 31.5. Okay? And so it says the last question, which is a kind of a culmination of everything here. It says, write the perimeters as a ratio first to second. Okay, first figure was 42. A ratio means a fraction, remember? So 31.5. What do you notice? Well, it's always a good idea to always reduce fractions, right? And so I'm going to see if this works on my calculator without the sun getting in your way. I'm going to go 42, fraction button, 31.5. Now most of you are like, that's not going to reduce, it's a decimal. Hit equals. Oh, I couldn't do that. So let's do plan B. Let's go 42 divided by 31.5 and hit equals. Now, it says, what do you notice? If you look at your calculator, this makes 1.333 repeating, right? If you take your similarity ratio, so our sim ratio, it was 4/3. Hit 4 divided by 3 in your calculator. Look what you get. You get 1.33. So what do you notice? Here's what you're going to use down the road. Your similarity ratio is always the same as the ratio of the figure's perimeters. That's going to come into play down the road, but you just figure that out on your own. Okay? So I hope you enjoyed lesson 2. A lot of this stuff, again, you know, it's just working with some ratios, but if you have questions, let me know in class.